Hi everyone, thank you for attending. I'm incredibly honoured and proud to put this on. And before we start, I wanted to say thank you to the APM Midlands branch. I did a previous presentation on this to fine tune, and the APM and the APM Risk for supporting, and hopefully we'll put on a great webinar for you today. It's actually the reason I was elected to the APM Risk was to promote integrated cost and schedule risk analysis. So it's job done. I can retire now. And then we've got to say a quick happy 75th birthday to our King today, King Charles III. And it's also the 101st anniversary of the first BBC radio broadcast. So 1922. There we go. Apologies if I speak fast, or I'm trying to get through this content for you and really put this out there. Here's the overview. I hope you'll see that integrated cost and schedule risk analysis really does provide powerful insights as opposed to the separate QSRAs and QCRAs. This session's aimed, at progressive and pragmatic approaches that I haven't seen much out there about, so hopefully this can be shared and put out there. And the session's aimed, at projects at all levels. You'll see later on that there is no bad analysis, and the sort of analysis you can do to get involved with integrated cost and schedule risk analysis. We're in scary times. High Speed 2, which I'm on now, great fun. 2010, they did a 32 billion tabletop exercise, of cost, and it's now 100 billion. They never understood the components and the complexities. So I'm hoping that integrated cost and schedule risk analysis is at the forefront of project assessment going forward. And I said, there we go. So it should be executed on major projects and programs. So introduction, quick one about myself. People, plant, process, performance, and prediction. There's a little 5 Ps that I live by. Some quick information. It's quite scary. Major rail, 100 billion of programs now in scary times. I've lived and worked in Europe, USA, Canada. I was a top international student in my business accounting diploma in Canada. That was a fantastic experience, and then I went on to work at Bruce Power. We might hear about that later. And 2 years at Coca-Cola in IT, European IT, which has given me I've worked with some fantastic, experienced people, and learned so much from them. And hopefully this is giving back. My favourite TV series, I just want to put a plug, is The Blacklist. It's just come to a conclusion after, I think, 218 or something episodes this last weekend. And in there, the one word I'll say is rage. Basically, rage against the system, rage against people, until, if you really believe passionately in something, keep going. And, I'm here, and, also as part of the APM Risk, willing to support anyone if you wanted to do anything on risk, webinars, etc. Oh, and there's my sidekick. People ask, where do you get inspiration? It's probably out walking my dog, to be honest, not sitting at a desk. And there we go. A few bit of industries and sectors that I've worked in. Just a little word play. £1 billion opportunities. So I just thought we'd start with something base plating. So there was scarcity of development space, shortage of housing and facilities. There's actually a thing called now air rights above. They're called air rights above railway tracks and stations. Hudson Yards in New York is a 25 billion development, and it's got its own energy supply if the rest of New York goes down. Fantastic, I think, on Impossible Engineering episode. And where are the potentials? We've got Houston. I've been pushing for this actually the last few years. They've actually frozen it and looking to do that now. The rest of High Speed 2 possibly could have done it. And then even looking at a possible phase 3 going to Gatwick and Heathrow under the Thames, and Heathrow and Gatwick and beyond. And, there's all these possibilities out there that we should be looking at. There's some links to that Hudson Yards development, and I'd absolutely highly recommend looking at those for inspiration. It's a great episode. So, integrated cost and schedule risk analysis. Just before we go in, all data here is randomly generated and not a fixed view. For all you integrated nerds out there, please be warned, it's killing me too. But why do we do it? This is all about value for money and offering the best insight we can to programs and projects, really pushing the boundaries and driving forward with information for our leadership and executives to make decision on. So the problem, I'll read this very slowly. How do program and project managers make decisions to provide best value to mitigate, recover, expedite, or buffer the schedule, including duration and estimate uncertainty, risk, and schedule logic dependencies and constraints? We always have cost contingencies, cost contingency management. What about time? So what do program and project managers do about this? Are they guessing? Where's the change management and where's the assurance? This is the challenge we need to put to our projects and programs to get the right information to assess what we do when making decisions about the schedule. So the problem, people say, there's no process, we haven't got the experience, risk mapping takes too long, schedule and cost information's misaligned, software's hard to use. Most time is actually spent, I'll just put the other ones, most time is actually spent, believe it or not, currently in resolving problems with scope, the WBS, schedules and cost estimates. And it's not ages performing a simulation or analysis as people think. And unless very detailed, this process should not take more than 1 to 2 weeks, if not real time. We're really pushing. I think the Project Expo was just on recently, at Wembley recently, and a lot of this time we're driving towards real time integrated information. So I really do see this as the future. So yeah, really pleased to push this out here. The benefits of integrated cost and schedule risk analysis, we'll see later, it removes the risk mapping every quarter. People are just taking their risks, mapping them, decomposing them, and this drives you'll see it drives real conversations. It drives accountability and engagement. Just on that point, it creates fantastic redundancy. And I don't mean getting rid of people. What I mean is everyone involved in the project and program involved and aware of all cost, schedule, quality, and decision making and assessments. It utilises the whole team, a greater understanding of and awareness of the drivers of what could happen with your schedule. It will improve your change management assessments. It matures your schedule and cost estimates with both talking to each other. It provides a joint confidence level. We'll explain that a bit later. It provides superior budget and cash flow forecasting and enhanced change management and contingency management. So the basics of projects. You've got your scope, which is your time, cost, and quality. Your assumptions, exclusions, and dependencies, and these are very important to keep track of these and continually review them. You have your work breakdown structure, your organizational breakdown structure. And I'm just going to, go back on that. This is your project organization, not your company. So people might solid line into a manager for financial and timesheet purposes, but we're talking here about the project organization. In that same person will report into, say, a project manager as part of the project. So it's important to understand that OBS. A RAM, which assigns, is basically the cross-section of your WBS. It details what work they're doing and who's accountable for that, the person responsible. And your control accounts are where you measure performance elements in your WBS. Work package. Generally, these are, specific pieces of work performed by a company. Activities, and we normally have earned value techniques on those. Resources, so people, plant, keywords, and then logics and constraints, so dependencies, availability of resources, And then decomposition sometimes, and it's normally is the future, and normally in planning what's called planning packages, and they decompose, say, a year and a half, 2 years before, when you know, over a massive schedule, you may not know about tools, techniques available, so you leave them as planning packages. It's one of the problems I see actually on here is that people try and put things like engineering breakdown structures, asset structures, location structures into their WBS, which is wrong. Your WBS should be defined as there, and then you can have columns or categorize each of your activities for, say, the asset breakdown structure or the engineering breakdown structure, and then you can view your schedule by those structures. So the schedule, so we mentioned we have the WBS, and then we have the OBS, and then we have the control accounts. So we just see a control account will represent a piece of work, and someone from the organization will be responsible and accountable for delivering that work. Underneath there, we'll have work packages. Then I've just done a second one, again, element of WBS and OBS, and a third. And then we have the logic between those. Sometimes that logic's not simple. Again, we can have, many. Logic is very keen to understand the key interfaces and the interdependencies between those. And generally, those will go on we mentioned before, assumptions, exclusions, dependencies. A work package will define dependencies. So that work package will define a dependency on that work package there, which is external to that control account. So QRA, the basics. We have a base estimate. We have estimating uncertainty, and there are two elements of that: duration uncertainty and cost uncertainty, which we'll come to in those later. We have risks, which are both threats and opportunities. We normally conduct workshops and interviews to get those. We have distributions of those risks. We call it the dark arts, when people mess around. There's actually been a very good article on distributions, and it's actually the logic is most dependent on the outcome, not the distributions. That was a good, very interesting article lately. Correlation. You can correlate by things like, normally there's a correlation of one risk and another. So one risk will be, if one risk happens, there's a correlation that another one will happen. And you can assess those and apply correlation matrices. Some people correlate by risk breakdown structure, some by project phase, etc. But there must have some substance to it. Also a warning here over correlation over many years on major programs, when it might not necessarily be a problem, or there may not be correlation across many years. For those theorists out there, we're planning to do more sessions later on or next year. There are things like eigenvalue tests and Pearson correlation. It depends on the type of correlation you do, but we'll just provide an overview here and hopefully providing more detailed sessions. The more detailed your schedule is, just a word of caution is that the harder it is for scenarios. So then we do the simulation. After we've got that above, we carry out scenarios, and then we get outputs, and we'll just show some samples of those later. And contingency, as we mentioned before, not just costs but time as well. And there, the key thing is, as we go forward briefly quickly, you'll see. I'll skip over the slide because the only difference on the QCRA and the QSRA is that element there. So QSRA, we're going to go through QSRA, then QCRA, then we'll go through the integrated. So you'll see here, I'm just going to put this up. You'll see the difference just before is that we've got duration uncertainty. And the last thing about the schedule is, I said about there's two things. One is about schedule quality. It's very important that there's often long time spent to correct the schedule, but it has to work with the modelling software too. And there are checks we'll mention in a second to check this schedule of your quality, and these should be done, as part of the ongoing schedule process. And the other thing was, if you do have a complicated schedule, it's very hard to do what if analysis. What if I remove this scope? What if I use alternative methods to do that? So it's very good to have a pragmatic, strategic, and a summary schedule. And again, we'll cover that later. So schedule quality, we have so many problems fixing schedule qualities. And here are 4 techniques and approaches to assessing schedule quality. I would strongly advise reviewing all of these above, and also if you're getting any scheduled software, ensure it has, I think the main one is the DCMA. There's a 14-point check. We won't go into much detail here, but it's a massive check on the integrity of your schedule and quality of your software. Defense contract, military assessment, I think it is, or it comes from the US, and I don't think there's any UK equivalent at the moment. Components. So here we go. We have the base duration. Then we have duration uncertainty. When we apply these, so on these are fantastic approaches using 1 to 5, 5 bands. So you band 1 would be low maturity. It might be plus 100%, minus 20%, whereas band 5 might be plus or minus 2%. And it's a very quick way. Again, you can add that as a column in your schedule to quickly find out how accurate you are with each element of your schedule, and I've used it really well. And on that point too, I'm very health and safety and environment conscious. That similar technique, that 1 to 5, you can actually have a column in your schedule that assesses the health and safety and environment impact for each of those activities. And it's a fantastic way to help your health and safety and environment team to identify what elements they need to concern on, and also possibly provide training, targeted training rather than generic. And again, I did that for a health and safety manager in Canada when I was at SNC Lavalin on the light rail transit in Ottawa, and he just said, "Where were you 30 years ago?" He thought it was absolutely fantastic. So please do take that away. You have activities and resource loading, calendars and constraints, and then after the duration uncertainty, we have the risk element. It can be risk can have a negative element. Duration uncertainty, can have a negative element. Risk again can be, have opportunities. Multiple risks can be mapped to one activity. Risk can be negative opportunities. Correlation, we mentioned, can be applied. And all elements combine to generate a duration for each iteration. So there are many iterations in one simulation. Some people have 1,000, some 2,000, some 10,000. Generally, they converge. I've generally found that 2,000 is more than enough. But some people, there are convergence, what we call convergence, where no matter how many more iterations you do, it doesn't make any difference at all. And then we can have different simulations. So we can have the current, so where we are now, the position we are now. We can have a post-mitigated, where we think we're going to be at the end of all our mitigations, our actions, responses, controls. Where we want to be, our target. Again, you can have those different simulations, but I didn't want to confuse things here. Like I said, the first session, and just you can have those, and you can look at each of those to see where you run simulations on each of those positions. So there we go, just an example. It's a dummy schedule. Sorry, the RAG just usually use critical path, but just ignore it for now. Again, this is dummy data, and you'll see you normally have it's a combination of your days and your logic, your duration and your logic that produce an end date. So we can also assess other things like key milestones or key activities, but we'll just concentrate on the end date here at the moment. So here we run, I've just mocked up a dummy iteration. So we've got the base duration. I've just ranked the duration, where they are, the duration, so you can see how they change in a second. So you've got the duration uncertainty, again, randomly simulated. The risk, again, some can be negative and opportunity. So we've got the iteration duration, the base plus the uncertainty plus the risk, and then iteration. And then you'll see the rank, and you can see sometimes, look, that's gone from the 12th biggest activity to the 5th. So again, you can see how much the significance can change. So that we generate those iteration numbers, and we plug those into the schedule, and then it generates with the logic another date. So you if you'll notice that the actual what we call deterministic, so the original start date was the 16th of October 2026. So you can see, just with a few risks, use the plain schedule at your peril. And to be honest, if you had key milestones, you would be monitoring that throughout the lifetime of your project. So here we go, and then another simulation. Another iteration. So this will be iteration 2. Again, we plug those values into the schedule and get a different date. And then what we do, we produce outputs. So we've got the schedule, and we can plot those in a table. There are two types of reporting. Some people like tables, like the one on the right there. Some like S-curves. Some people like that you can have bars, solid bars, instead of the S-curves. Again, different people, different ways of producing those outputs, and I'm hoping to do another session next year on those outputs. So here we have a 25th P25 called. So what that means is, out of, say, if you run 1,000 iterations, 250 of those would come. The end date would be on 16th of October or before. So we would have 25% confidence that we will achieve that date. So 50%, we have got 50% confidence of achieving that date. And P90, generally I see P50 is normally given to the project manager to manage. The P80 to the program to manage as contingency, and the P90-95 to a company to manage. And generally, a lot of executives and lead P values it's all the leadership and executive want, all the leaders and executives wants. It's very important note here is that last few years really noticed that it's extremely important to mention the extreme P100. So obviously, what's the maximum end date? We give ranges at the moment, but it's important to mention that in any narrative and say what is the maximum of your simulation. So we get outputs which are key drivers, which activities, uncertainty, risks are most influential on the end date or milestone. That we have criticality index, the probability the activity is on the critical path. So it's sensitive. Some activities might not be on your original critical path, but they may well be when you introduce uncertainty and risk. Significance index, the relative duration importance of an activity. The sensitivity index, which is a combination, multiplying the two previous ones, again providing insight, and then cruciality, which is your duration, total duration correlation. We can do resource analysis. So our resource is busy. Do we need to get in more resource? Do we need to overtime? It's just a key point here. We're very poor on whether we need to put some overtime in. It's like people think of it as extra spend when it's not. It's really key to understand these things, to focus on when you do need to possibly pay resource more to do more in a short space of time. And again, very little of that done nowadays, but it was previously. It's gone away because of cost-driven decisions. But we should hopefully return to where we've got information. So that was QSRA, Quantitative Schedule Risk Analysis. Just the S changes with a C, Quantitative Cost Risk Analysis. So QCRA. Again, I'm just going to put the basics up because the only difference is that cost uncertainty. You'll see the only difference is that cost, and the rest is similar to the schedule and the overall QRA. So QCRA, base cost. We have our cost uncertainty, and again here. There's the American Association of Engineers of Cost Management International, the AAECI. There are guidance on those bands I mentioned financially, plus or minus percentages. And again, each of your elements of cost should be attributed to one of those, if not more accurate, if you can't provide a more accurate one yourself. And so there are very quick ways of doing cost uncertainty. And then again, we have our risk. Again, the cost uncertainty can be negative. Multiple risks can be mapped to one cost element. Risk can be negative. Correlation can be provided to cost elements, and all elements combine to generate a cost for each iteration. And again, the simulation has X iterations. And again, those current post-mitigated target simulations. One key note here on estimating uncertainty. I was actually, at Network Rail recently, and we realised estimated cost uncertainty and duration was 75% of the risk exposure, overall risk exposure. And so it's extremely important to manage those elements. And what I would say is have those, you should have in your risk system threats, opportunities, and estimating uncertainty, and managing each of those components, which again, I don't see much of them, but again, it's when I was at Network Rail, we introduced actually they use a rail method of measurement, the RMM, so a standardized cost, and each of those elements of the RMM was an individual estimating uncertainty record, and it was managed, and it provided fantastic insight into the exposure and what was going on to reduce that. So here we go, just again a mocked up Excel. Again, I'll share these files later. We've got the base cost. Again, I put in a rank so you can see it later how it's affected. We've got our cost uncertainty simulation, a risk for this iteration, and the overall cost of this iteration. And you'll see here sort of like, some of them do have, they go through some changes from one to the other. We can see here that that was 6 overall, and now it's gone down to 12. So it does produce a change. So you generally, there's no schedule here generally with QCRA, what people do at the moment. And then you just simply add those to produce an iteration cost. And then again, second one, random iteration. And then you get a second cost. So and very similarly, we get the QCRA percentiles and the S-curves. And we get again, so we're saying there we are 25% confident that 1.649523 will be enough budget for this project to come in. Again, the P50, P90, and again, it's extremely important to mention that P100. The base cost was 1.649. So just there, even with a few risks that I put into them there, you can see the difference between the 1.6 and the 6.1. And you can see how very easily some projects blow the budget because they don't do this analysis. So here we go, integrated cost and schedule risk analysis. So hold on. I just wanted to, some people are they're just taking QSRA outputs, putting it into a QCRA model. That is not integrated cost and schedule risk analysis. We'll show and demonstrate here what is an integrated cost and schedule risk analysis, but taking the outputs and just multiplying a burn rate for a duration period from a QSRA is not an integrated cost and schedule risk analysis. But here we'll go through that now. So the approach, organisation and PMO culture is key. You have to have a good culture, and it has to be driven from your organisation. People think this should be driven by the risk team, but it's not. It absolutely should come from the top down. Schedule and cost systems are driven by the WBS and control accounts. We have generally cost people just siloed with their cost accounts, schedule, doing their QSRA, but it has to be together by the WBS and the control accounts. These are the key elements of work packages. These are the key elements of project delivery, and we have to have that cost information on there, or we don't know what the impact is, as will come later. Estimating uncertainty and risk are assigned to the schedule. So that's cost, uncertainty, and duration are assigned directly onto the schedule. We decompose the schedule jointly with cost. So I've seen schedules that go down to level 21, and we just haven't got a clue what's going on. Even when you do your summaries and you do your drivers, like we mentioned before, no one understands what they mean. But again, you have it with the best approach is to decompose the schedule, and it actually forces people to do it in a pragmatic, understandable way. Activities are reviewed holistically: time, cost, schedule, quality, and risk together, rather than siloed conversations. You can use application program interfaces, APIs, to reduce errors. So what that means is that your cost and schedule software are linked. So your cost has those elements, and people put directly on them, and you can feed those automatically. I think there are several software out there. I didn't want to mention anywhere here, but there are software which link your risk software links to the planning software and directly, so people put risks and duration uncertainty, estimate uncertainty directly on those elements in the risk system. We mentioned about control accounts. So again, things become accountable. I see a lot of the times pie in the sky risks where you don't have, you don't know who's responsible for them. They don't get managed. But if you do it this way, people have their risks. They are quantified in relation to that control account or work package, and it really drives performance account and mitigation quality. So again, you can have APIs with things like Power BI, Power Apps. So people are producing things like those Power Apps interfaces, which take information from your cost, risk, and schedule information, put it in a screen, and enforce the integrity there. I think there's some companies that are doing that now. Components. Here we go. So you'll see we have our activity duration and activity cost. Duration uncertainty, cost uncertainty. So remember those bands, we apply those directly, those 1 to 5s, to the activities. And again, we drive fantastic insight into what's going on and the uncertainty into what's driving uncertainty in our schedule, not just in a Excel spreadsheet, just modeling somewhere and summing it up. And then we apply the time risk and the cost risk together. We have direct conversations and challenges. So someone may say, oh, this is going to cost $1 million. And your planner may, and this is real, the planner will turn around and say, no, really, there's only cost impact for the first week. After that, there's nothing. And this is where it drives real maturity in your estimates, a greater understanding of estimating uncertainty and risk. Accountable elements, like I said, it drives ownership of someone who has to do something for an element in your schedule. We have things called joint confidence levels as our output. So the problem is the QSRA and QCRA results don't reflect combined effects. They're siloed. So what we get, again, mocked up data, we have a joint confidence. So we have our QCRA results on the vertical and our QSRA on the horizontal. And you can see, actually, you can pick a point and you say, in this simulation, we are 80% confident that we can come in on this time, on this cost. Just a thing about the joint confidence level. This provides better insight, more accurate estimating and forecasting. Just a point on here on the joint confidence. There are many positions where the 80% of time and cost condition is met. So we have what's called a JCL curve. So again, you can just see a range where you're in there. You can choose, where the confidence is on that curve, and again, you're making a much more informed decision. Cash flow. Again, we've the problem is cash flow forecasting is poor. People are, I've seen major problems where people do a cash estimate of a risk with no consideration of the schedule impacts, the logic or the constraints, and result really and then they say it's £1 million. Suddenly a few months later you realize it's impacted a major milestone further downstream, and suddenly it's a £5 million risk. So having that real insight into what's going on. I see finance professionals spreading risk across periods, just flatlining it between the start and end date with no materiality. There's an accounting principle called materiality. So that flatlining has no materiality at all. You can maybe do it as this process here gives you an absolute, credible, assurable position. And what you can see here is it's mocked up, but if you see your P, you might model, say, your P50 for each of those periods, and you can see, you can actually see, look, there's not much risk on that estimate for that month, but yeah, there's very risky estimate on that period. Of real insightful information to people so they're aware what's going on. And another final thing I wanted to point out is that if you spread a risk in financial years and you start in March, and in the UK we start financial years normally start in April, but if you did it in March and flatline your risk across 10 months, you've got 90% of your cost in the next financial year. So if you need it in that financial year and it happens, you've got no money in there, and it causes real problems. Again, this provides more accurate forecasting and insight. So integrated cost and schedule risk assurance, a lot of people do on the detailed schedule. You can challenge, if you're at the coalface, real working level on your detailed schedule, you may well do it, but you can provide assurance level. And like I said, the detailed schedules are normally incomprehensible by stakeholders and difficult to use for scenarios. So I've produced a guidance table for what I would recommend you do. So again, we provide, so I'd have a summary schedule by project by phase, and then as you go into initial design, we have the WBS. So we'd have our WBS elements when we should be assigning and thinking about that early on. And again, not an engineering or cost breakdown structure by the WBS high level. Again, that is should be a controlled document outside your project. Then we go into the detailed design phase. When you'd have your control accounts, what are the elements that you want accountable on that project for delivering. When we procure, that should be specific, companies and work package, possibly multiple work packages, control accounts, or WBS elements. But at the work package level, we'd have that schedule. And then during construction, commissioning, and handover, we'd have a work package and activity schedule. Key areas possibly as required. Again, decomposing. We haven't mentioned it. You can decompose in key areas of the schedule as you deem fit. And these provide a comparative assessment and additional insight. It's a waste of time. So a summary schedule. Here's a definition. The summary schedule should be high level, contain 100% of the risk, have all phases, deliverables, key milestones, undertakings, key sequences, key points, identify key logic, tactical relationships, and be sufficiently reflective, consistent, and aligned with the detailed schedule. Now, I would anyone who produces a summary schedule, challenge them for this with this statement and get a signature. That is what it should represent. And also, a tip is if you're producing one, start with maybe a detailed schedule at level 3 to 4, so just roll it up, and then look for logic across those components. Start there and build it up. And sometimes you can get a really quick one by doing that approach. So be pragmatic. These are pragmatic ways of assessment rather than detailed. Sometimes people say, "Oh, there's too many risks, we can't do it." To risk. So what you can do, you can use your PID. There's much said about them, but I find them extremely powerful. And this is how. So you can assess your key areas to provide a detailed analysis very pragmatically. And I've used this very effectively. You take your red risks. So you have your bands, red, amber, green for your categorized risks. So if you're not aware of a PID, it's your probability based in bands against your impact based in bands. And that's the highest impact of cost, time, or cost or time. And so you can have your red risks and take those. You can do an analysis with red and amber risks. You could do red and amber and a green total. So say you're doing it by project, by phase, you can have your red and amber risks mapped to components and then put your green risks at the end of that phase and just have 100% between 0 and the green total and simulate that. Very pragmatic, powerful ways I've used. You can look at your risks on or near the critical path, risks on activities with low float, and you can highlight key areas, like I said, and do a more detailed analysis. And the result is a pragmatic assessment. There's no bad assessment, and these are very quick, powerful techniques to get very quick insight into risk exposure on your programs. We're going to run through the benefits again. So again, it removes this mapping. Every quarter, people spending 3, 4, 8 weeks, mapping risks and breaking them down and then quantifying them. Put them on the schedule, put them on real work packages, get people accountable, assess them and manage them all day, every day. It drives real conversations about elements, what's going on, what's the impact, and really matures. We mentioned accountability, the engagement and behaviours across the whole team, not just siloed project working. It utilises the whole team and their experience, and a greater understanding and awareness of the drivers. Improves your change management. It matures the schedule and cost estimates. We get our joint confidence levels, superior budgeting and cash flow forecasting, as I demonstrated, and enhanced change management and contingency management, both cost and time. So the future, if you haven't been taken there already. So we've got outputs. The issue at the moment is outputs don't provide decision-making information. A few things that we need to look at in the future. What's the most cost-effective? Where are the most cost-effective activities? Not necessarily just now, but in the future to expedite the critical path. People think, we've got to expedite the current activities to get back on the critical path, when it actually might be much cheaper. We might find a much more cost-effective way in the future to pay double time or so, what it is, work double time to reduce and expedite, reduce the critical path. But, which activities are most likely to increase the overall cost, not duration? Again, we can manage these more closely. Which ones are most likely to increase the critical path and overall cost? Where are the biggest cash flow periods? As we mentioned on that, not just pro rata in money and having no idea of what's going on. Where's our highest cost path or critical path? Different things sometimes. Again, should be aware of those. Where's the highest labour cost? Generally that's where you're going to expedite with your critical path. Materials, so we can be aware of when those high cost materials are coming in, and the result of those things will be the much more powerful decision making insights. Schedule management. So we've got another issue is inability to see where schedule and cost programs are at once. Again, I said ignore it now, but now we can actually see these are our highest cost activities, so we can visually see when and where they're occurring. And again, graphically visualize what's going on. Where's the best place to speed up the schedule? Maybe the best place is, that's high cost. Maybe we can choose an element there that but on a critical path and reduce it there, rather than doing it if you're on that or that one, but it's at your peak cost. It provides a deeper analysis and targeted areas of approach for reducing your critical path. We've got risk algorithms, where we've got a problem where there's bias in estimating and a lack of historical insight and trending. Historical information we use to predict it. Combine data across companies, industries, and countries to get an insight. We can do the same as schedule as we can with cost. We've got schedule out there that's doing it separately with schedule and separately with cost using artificial intelligence. Sometimes they just use text to forecast. Machine learning provides continuous refinement, but it may not suit a first of a kind or unique project. And again, like we've got schedule, artificial intelligence, reference class forecasting. I'm asking for cost AI at the moment and combining those to provide a much better insight. We've got trend. Here we go. We might say our current forecast is here, our end dates based on our suppliers' last 6 months forecast. We've got those dates based on their 12-month forecast. We've got this date. So we can have real conversations about, is your schedule good enough? Are your activity estimates correct based on your previous performance? And so again, increased insight and assurance. So the conclusion, organisation is key. Culture, this has to be driven top down. Schedule should always drive the project. Always. It's an iterative process. Decompose schedule and cost at the same rate. Schedule first, then cost elements if you need. There's no bad simulation. It's iterative, engaged. It should be an engaging, absorbing, insightful process. Try to automate so many errors when people are exporting and doing things manually. And really look at integrating your schedule, cost and risk software using APIs. It's far more efficient, effective and insightful than siloed QSRAs and QCRAs. It's a journey, not a destination. That was the saying on my 1999 London Marathon. I've also done the marathon in 2009 in London, so I've done it in 2 millennia. It's my claim to fame. But engage people, embrace them, and empower them to produce this. And I'm just going to go to leave with a quote. It's a spin on a quote from Edmund Burke, an 18th century Irish statesman who was a member of the British Parliament in 1766 to 1794. The only thing necessary for the triumph of cost-driven programs is for good risk PMO project controls and planning professionals to do nothing. How have you navigated the communication of QRA results when you know the client organisation may not like the outputs? The worst case is different to their expectations. Again, this is all about integrity. And it's understanding it's a range, and it should be an iterative process to reduce that and manage that range. I would actually be concerned if people aren't publishing those ranges, because I'd be concerned that they weren't managing or giving a real picture. So if I was someone senior managing or overseeing these projects, on the executives, boards, government, whatever it is, if I didn't see this range of uncertainty, I'd be worried that it wasn't being done and wasn't being managed properly. So it's about being open and transparent and managing those things, like, the elements. Do you have any more in-depth analysis on how you create your calculations? There is a fantastic book, I've learned a lot, and spoken with David Hewlett. It's the only one out there on integrated cost and schedule risk analysis. I will put that in the chat on the APM community. Please do contact me. But there is a book entitled Integrated Cost Schedule Risk Analysis by David Hewlett out there on these techniques, on some of those calculations. And again, we're hoping to do a future webinar on that in the next early next year. I think that's it at the moment. The only thing I was going to say is thank you very much for attending, and everyone who assisted in making this happen. Please do join the APM Risk SIGs and the communities on the APM website and LinkedIn, and feel free to connect with me at any time. Thank you once again. Just if you scan those, if you've got your mobile phone at the ready, there's a link to the APM events, so keep an eye out on there. And the APM Risk SIG, please do join the SIG and get involved. And really looking forward to hearing your integrated cost and schedule risk analysis stories and progress.